Okay, I know, like I said, you're expecting Charlie Bogart today, so I hope you'll enjoy this. Um, what I've been working on is installing a simplified CTC. All right, so about I try to get once or twice a year to go visit our old friend Jim Petro out in Reno. And about 3 years ago, I was out there, and Jim's probably 2 3 years ahead of me in many ways. But speaking of the layout, and he had done some signals, and I said, "Boy, this is pretty nice, Jim." And he said, "You could do that. Do tell." And he said, "I have a guy." And of course, he has a guy. He says, "Let me introduce you. Russ, this is Dennis. Remember that name, Dennis." And Dennis is a retired UP signal maintainer, and he also knows his way around level 4 Arduino programming. Now, our own Mike Berry here has done a couple of clinics on Arduino programming, but Mike will admit what Dennis has done, especially on some very complicated areas of the layout. It's level 4, level 5 programming. But Mike has been very instrumental in making the bridge between Dennis and myself, and helping me get past the learning curve. Um, so Dennis says, "So you want to do signals, do you? It's going to cost you a lot of time and a boatload of money." How many boatloads? A couple. Oh, well, what the heck? Why not? So, 2.5 years later, and two boatloads of money, the whole layout is signal. Now, I'm giving you a little prequel to the CTC because it will be based on the Signal Arduinos. So, uh, so now all of the signals on the layout are New York Central prototype. Um, and this was a nice one over at West Buffalo that was kit bash, believe it or not. This is a 4-track bridge that obviously right here was just on 3 tracks. So Steve Lasher was and I kind of got together, and this bridge started out, it was flat etched brass, so it all got together there. Steve scratch built this bracket mast. Uh, these are the heads are showcase miniatures as a dwarf, but Steve basically scratch built these signals, and the dwarfs were a kit too, and uh, they're only a one head kit. So Steve very meticulously mounted the second head and cleverly hid the wires going down the back. So it really looks nice. Okay, so when I decided to do the Signal project like Jim's, it's all based on Arduino processors. I didn't want anything that had a computer involved with it because there seems to always be some problem if your operating system goes down or it needs an update, yada. So one might argue that the Arduino is a mini computer or processor, but it stands alone. It right there, it does everything it needs to do. The actual, whether you want to call the pin board here, um, like a decoder, and the Arduino, the motherboard, is that um, if you'll see in the next slide that all of our inputs are going to be put on this, and the actual Arduino processor is behind this. So if something happens to the Arduino, we just pull this out. I get another one. Mike comes over, puts the program back in it. We're in business. So pretty neat stuff. Over here on the right is your block occupancy detector. So a lot of these wires are going to be put in certain pins. Dennis sends me a spreadsheet that has all the pinouts on it that the numbers will go into the certain numbers on that. We doing okay or okay? So you see later on we're going to build on top of this. All right, so you'll see in the next slide that there's a whole bunch of spaghetti going to the Arduino.
Sorry.
No, it's okay. Yeah. Okay. Okay. Yes, no. All right. So on our bridge here, and I don't know if this is, but this will be for the signal talk, but the center targets here are hard wired red all the time. And I won't go into explaining you why, but the top and the bottom targets all have a tricolored LED in there. So we have 18 different colors that, yes, all have to go to the Arduino here. So, so you can see just like here, here's the red, yellow, green, red, yellow, green, and da-da-da-da. It's just duplicated all throughout that. Nice about these block detectors right here, it has a little LED that when there's something in the block, that lights up. So again, that tells the Arduino something's in the block, you need to change the color, you need to do this, all's great. All right, so now we have the foundation to start working on our CTC. And so last year, when we were out at Jim's, and he usually has an op session while I'm out there, and Dennis is his dispatcher. So towards the end of the session, Jim says, why don't you go back and Dennis will show you a few things that's going on. It's like, this is really neat. And it's like, so you want to do CTC, do you? And it's like, he said, it's going to cost you more time and maybe only one boatload of money. It's like, oh, well, what the heck? You know, we're halfway down the rabbit hole. Let's see what the Cheshire Cat and the Mad Hatter look like. So Jim, Dennis, and I kind of put our heads together of what we wanted to do, what was going to work for my layout versus what they have on Jim's layout. And one of the things was I wanted to be able to, just like they can at Jim's, be able to throw the turnouts without the computer being on. And we decided that, again, the way my layout's set up is just certain turnouts will be thrown on this. And back home here, we got Mike, Fred, Ron, a couple of our station masters together and decided on what would really work best on mine. And if you haven't been to the layout, there's three major areas: Albany, Syracuse, Buffalo. At the Syracuse and Albany, there's almost always some movements going on there. So if we had every one of the turnouts dispatcher controlled, then you know the yard masters would be saying, dispatcher, I need control of this turnout. So we said, let's just eliminate that. And again, mostly major crossovers, major passing sidings, so on like that. would be under dispatcher control. Also, I wanted to have the signals in ABS state versus CTC. If the way it works on gyms and in real life, that all your targets are red until the dispatcher selects that route. Once that route is selected, then the aspects will change whatever color is appropriate for that routing. Okay. So again, since we're only going to do certain turnouts, we don't want to have all the signals red all the time. Besides, I like colors. All right. All right. So let's start now with our CTC program. So this was on Dennis's work station before he sent it to me and tested it all out. So here's the interface with the computer, and it goes to, wait a minute. You said you wanted this done without any laptop or computer system. I lied a little bit. The plot's going to thicken, so stay with me there. We really don't need the computer to still do what we do. We just won't be able to do as much. So now we have the interface, and these are, again, Arduinos, but they're a little bit different. They're called Leonardos. So we'll refer to them as Leonardos, but they take care of the different areas of the layout that we wanted the dispatcher to control. And they're all daisy chained with Cat5 cable, and your signal Arduinos are all on a 5-volt DC system. So are these. So that works out pretty nice. All right. So again, more spaghetti. As I was growing up, I wanted to work for AT&T. So here's my big chance. So the Leonardo's down here, and it's going to piggyback right on our signal Arduino. So in other words, when we detect something in the block, right, it sends a signal over to the Arduino, change the color of the aspect to whatever is appropriate. The Leonardo picks that up, and what it's going to do, pardon me here, this is the pinout of what Dennis sends me. And in this column, this is where we started out, where the different blocks from the BOD go to the signal Arduino. And then these are coming off the Leonardo that kind of piggyback on those. And again, this is what you get. The toughest part of this project was taking my tweezers and kind of looking for the numbers back here, backing the screw out to put these wires on top of that. Yeah. And getting them in the right hole. So that's what chewed up a lot of time. But you can see again where if a train is detected in a block, it sends a signal over here. The Arduino changes color. It sends down here to the Leonardo, and it says, okay, there's something there. I'm going to put a red line on the JMRI screen. So now the dispatcher can watch train movements throughout the entire layout, except for staging, and this stands for Buffalo Central Terminal, the passenger station, where we don't have any need for this dispatcher in there. So that's where the gap is. You'll see in the next slide, I don't like this 100%, but we have a train coming out of Detroit, and he's crossing over to what we call track one, and it's continuing. You'll see in the next slide, there's the signal gap is right here, and right here, and right here. And so what happens is when a train comes over here, it also, you get a occupation gap or sensing in this area and up to where the next gap is there. But the train is actually coming down track one. You'll see also here, like the same thing at Syracuse, where we have passing sidings. There's a train here, but you notice right here is where the gap is for this signal block. So you get a little red here, a little bit red here. If you can pick it up at home, you can also see just a little bit of red down here and down here on the crossovers. Okay, so this now, this is a little bit smaller to see, but you get the idea is here's where the signals are here, so you have a gap, and here's where they are down here. So that makes sense of why when a train's coming down here, you would get red here, red up to these guys. All right, so that takes care of where the dispatcher can watch a train throughout the system. Now, let's go ahead and introduce how he's going to manipulate the turnouts. So we have an intelligent turnout controller, or ITC. Let's call this the smartphone of the tortoises. And Seth Newman, who again is a friend of Jim's and Dennis, he has model railroad control systems. Matter of fact, Stan, as I, have a very small motorized switch machine. Stan bought one. It's these guys who make it or sell it. He has a bunch of different models. This one, if you look, it says, no. There's enough that would slip right up to the tortoise edge board there. And it's like, yeah. So how neat. So all I have to do is slide this right up on the tortoise, put a bunch of wires there, and we're in business. So here is the quick and dirty diagram, if you like, that he has made up that corresponds to this. So, all right. So now this, remember that our signal system, our Leonardos are on a 5-volt DC system. Our tortoises work on a 12-volt, right? So this takes 12-volt input to this, and you can use down here. These are the things like if you want to power the frog, have whatever the tortoise contacts to do whatever you want. On mine, if you haven't been there, that for some of the turnouts that are in the fascia, before we had signals, pardon me, that if they were, if the turnout was in reverse, you'd either get like a flashing LED on the fascia, red or yellow, alerting anybody running a train that maybe the turnout is not aligned to them. So we can use that to again do the flashing LED. Okay, local throw. That sounds like something we can use to do right there at the panel, like we've been doing all along, and remote throw of what the dispatcher is going to do. So, like I said, this is the smartphone of the tortoise. All right, so this is the Albany panel, and this is one of the crossovers that is going to be directed by the dispatcher. Now, panel looks all nice and neat and pretty, but if and what I'm about to show you is not the same panel, but you'll get the idea, is that, oh my goodness, holy spaghetti, Batman. So, yes. Yep, that's what all the fun is. And now a lot of this, these are the wires going out to the different tortoises, and these are all daisy chained, right? And the nice thing about the tortoise is that since it's a stall motor, when it stalls, there's resistance. So guess what? It acts like a resistor. So it's really neat that you can put your panel LEDs in line with that, and it's really great. You don't have to add a resistor to it. But we're no longer doing that, and so we now have to go to a single pole, double pole. And this happens to be the West Buffalo panel. And I was smart enough to start with this one. When we started the signals, we started with Albany. And if you come in the back door, that's Albany, and worked our way around the layout to that 3-track bridge. That was the end of it. But this one, I decided maybe because this panel is kind of simple, and let's do the learning curve on this one. And I'm glad I did it. So now I know that probably one of these crossovers, the toggle switch for it is going to be buried right here in the middle of the spaghetti. So what I could have done is really taken these wires off, and really all I would need is these two lugs or these two lugs to make this work. But I figured getting a soldering iron down here, and boy, that'd be just trouble. So it would be easier to take out that that double pole double throw and use the single pole double throw, because now the LEDs are going to go, they're going to go right to our smart tortoise machine here. And the ITC is going to know, like, okay, depending on where we put our wires on this board, it's going to know, okay, the switch is normal. I'll illuminate that LED. If it goes to reverse, I'll illuminate this LED. Like I said, it's a very smart little guy there. So that's why I decided to go with the single pole. That's all we need here. And again, these LEDs now go directly to the ITC. So a lot easier if I have to get into all that spaghetti, just unsolder everything and make it much easier that way. Okay, so here's that West Buffalo board. And so now, if this will be under dispatcher control. So no matter where these toggles are, if the dispatcher wants a through and selects this, so we're going right through this, these LEDs illuminate just like they always have. And now if he selects this, it will be local control. And when somebody comes out, for those of you that don't know the layout, there's some industries back here. So if we have a train that comes out that's going to do some switching moves, he calls the dispatcher, say, I need control of 11, 13, so on like that. He goes click, click, and now they have local control just like it's been all along. Now, here's the thing, like, you know, a number of slides ago. Here's the neat thing about this, and what I didn't realize a year ago, after Dennis and I were talking, he had to go home a little early before the ops session. So he announced to everybody, he says, guys, I got to leave. You're now in ABS. I assumed that he shut down the computer. Not so. So after I started getting this, I said to Dennis, hey, the Dell is off. I have no control. He goes, well, you won't. You need the Dell on to have local control. Oh, heck, it doesn't work that way. So again, nice that he and Seth are good friends. And so what they did is they changed the chip. And here, watch your eyes. So there's two chips. One is a motor chip to tell the tortoise to go or not, and the other is kind of like the logic chip. So they just reprogrammed this chip. Uh, the new batch, whoops, sorry, the new batch of ITCs come with this. So now, just like I talked about, if the Dell goes down, unfortunately, the dispatcher will not be able to see any trains on the screen. He'll go back to the old-fashioned way where crews will have to OS. And go, okay, fine, they're on their way. But the crews, the toggle switches, will work just as they're working now without the computer being on. So that's the real nice thing about this system. All right, so the other neat thing when it is working, and I don't know if this up here is blocking it at home or not, but you'll see that the top targets are red, yellow, yellow, and guess what we have here? Red, yellow, yellow. So again, the Leonardo is getting information from the Signal Arduino and putting it right here. The same, here's the westbound interlocking. You can see we have green, red, red, and green, red, red. So it's a pretty neat system. But again, and that's why I didn't want the signals to all be CTC oriented, because again, if the computer goes down, then everything gets messed up. But right now, these are working on the same system without the JMRI being on or anything. So it's I'm very, very happy with it. Matter of fact, when I say goodbye today, I'm going to run home. We have a screen share with Dennis, and he's going to do some more updates to this. So nice that between FaceTime and screen sharing and everything that I can talk to him 2,000 miles away, and I would have hated to do this 20 years ago. So, matter of fact, Dennis had said, I can actually dispatch for you if you want. And I keep thinking, yeah, I wonder how much might go wrong 2,000 miles away with internet loss, but we'll let Fred do that. So, anyways, that's the simplified CTC. The wiring might be a little complicated, but once you get past the learning curve, again, it's just sticking the right color in the right hole, and for the most part, that's working out. And unlike the guy that Fred visited, I'm afraid my dispatcher's corner is pretty simple. But thanks to Mike, at one of our meetings a while ago, it just came up. He says, I got this couple of monitors that are collecting dust. If you know of anybody that needs it, as a matter of fact. So I inherited this from Mike. Thank you very much. So, there's the Dell, and now Fred has a nice big screen here. And once again, just like up till this next op session coming up, Fred will write, get calls. He'll write down stuff just like the old-fashioned way. So you know, we can do either or. We don't need the Dell. So that's all I have. Thoughts, suggestions, inputs. Okay, thanks. Appreciate it. Okay, sir.
Questions?
No, that's it. No questions.
Okay, that's it. Shut her down, Fred.